Ooh, that was quick. All right, what's slope?
It's like how.
It's like or it is?
It is.
It is.
It is how, like, steep a line is, I guess.
You trailed off there at the end. How steep a line is?
Yeah.
Or what's the opposite of steep?
Or.
Jen.
A line's rate of change.
A line's rate of change. I like the use of the word phrase rate of change, but what about the line is changing? See what I mean?
Yeah.
We'll come back to that idea of rate of change in a second. What were you gonna say, sir?
Well, she said what I was gonna say, the rate of change, but you say like the increase or decrease
Of?
of rate of change?
Increase or decrease of rate of change? You get into some calculus terms there. What do you throw in there, Chris?
Like rise over run.
One way to express it is rise over run. How else can you express slope? I'm sorry?
Y over X.
No, not y over x.
Y equals x plus b.
No, that's an equation of a line involving slope, because m stands for slope, and I have no idea why m stands for slope, but rise over run, good. Any others?
Is one y equals mx plus b, or is that something else?
That's the equation of a line using slope, Julia?
Changing Y over changing X.
Yes, but I can't remember if that's the second one or the third one, and if I click on the second one and I'm wrong, it's gonna, I'm gonna live on the, hold on, let me see what, Colin, what do you got?
Y1 minus Y2 over X1 minus X2.
Oh,
Oh, one.
okay, now I know, it's a good thing I didn't click. There it is. Okay. So all of that stuff that we talked about is true. It's the steepness of a line. It's the rate of change. Okay, slope can also refer to rate of change, depending on how you're defining the slope. And then three different ways to express it. Rise over run, the slope formula, the middle one is by far the most important, and then we also talk about delta x. Change is delta, that's a delta, lowercase delta, delta y over delta x. Questions?
That's what I was.
Yeah, those are deltas. Oh, actually, that's not a lowercase delta, that's an uppercase delta. A lowercase delta looks like a sad D. 4 different types of slope. Positive, negative, 0, and undefined. As it says down here, why is that slope undefined? Because I'm guessing in algebra last year you talked about this, and you talked about any vertical line has an undefined slope. I'm not sure, however, if you talked about why it's undefined. What makes this slope 0 and this slope undefined? Done.
Well, our math teacher last year kind of explained it as like
Oh, do tell.
a mountain.
A mountain.
Like, you can't climb a mountain when it's like straight up like this.
It's a little difficult.
Yeah, you can like just climb the one where it's like that.
Yeah, but if it's like this, is it a mountain?
I don't know.
What do
I
you
don't
got?
know if he just says a mountain.
Well, since it's changing Y over change in X, there's no change in X, so you can't do it.
Beautiful. Okay. Nailed it. Okay. In this case, there's no change in x, as she said. So the denominator becomes 0. And you can't have 0 in the denominator in the math that we're dealing with here. It doesn't work. Okay. Why is this one then 0?
Because in this case, 0 is in the numerator.
Correct. 0's in the numerator here. 0 over a number is okay. That's 0. A number over 0, not good. Undefined. Okay. Calculate the slope. Make sure you know what you're doing. Careful with the signs. Don't burn yourself.
Thanks.
Do I really have only 7 minutes?
Yeah.
Oh, we're going faster then. We're picking this up. Here we go. Okay. Slope is it? Okay, what do you got for an answer?
2/5.
2 over 5. Anybody else? 2 over 5.
Yeah.
All right. Not that I don't trust you, but I'm going to do it just to make sure we're all on the same page. -5 minus -1 over -6 minus 4. That's -4 over -10, which is 2/5. Is that what you said? Beautiful. Any problems? Excellent. Let's move on. Hey, do another one. Let me see if there's a third.
Another.
Okay. Before you do the calculations, what's going to happen here before you even do the calculations? What can you tell me about the line for part B?
Oh.
Do we- I'm sorry?
It's horizontal.
It is... No, vertical. Because it's same x's. Okay, vertical, same x's, same y's, horizontal. So therefore, since it's vertical, what's the slope? Do we? Undefined. Good. That'll save you some hassles. The only difference between C is instead of giving you the points, I gave you a picture, but I'm assuming you could all figure out where those points are. Is that a safe assumption?
Pretty much.
Yeah.
Maybe.
Yeah. Turner, where's L?
-2, 4.
You counted wrong. -2,
Oh, 3.
3. Okay, good. So, safe to assume you can all get a point, and then just do the same calculation we did. Okay, great, beautiful. Okay, tell me about two lines that are parallel. What do you know about their slopes? Same, beautiful. M1 equals M2. What if they're perpendicular? Opposite? Reciprocals. What does that mean in English? Let's suppose the slope is 2/3. What would be the slope of a perpendicular line?
-3/2.
Good. Flip it over, change the sign. Okay. Or, if you're given two slopes, and you want to know something about the lines, you got 3 scenarios. They're different, so they just intersect. They're parallel, they have the same slope. Or, if you multiply the slopes together, you should get... Let me rephrase, let me ask my question again. If you have two perpendicular lines, and you multiply their slopes together, what will you get for an answer? -1 all the time. Okay. Product of their slopes is -1. So instead of having to recognize whether they're opposite reciprocals of each other, you can multiply them together and see if you get -1. If you do, they're perpendicular. Perpendicular is just a special case of intersecting. They just happen to intersect at a right angle. M1 times M2 equals -1. Or M1 is equal to -1 over M2. Same thing. Another example. So we want to figure out, we're running out of time here, so I'm going to skip this. If I want to know that FG is parallel, perpendicular, or neither to HJ, I'd have to calculate the two slopes, then look at them. They're going to be the same, they're going to be different, or they're going to, or their product is going to be -1. There's no other possibility. It turns out that it's neither. Okay, one is -2, the other one is -2/3. They're not opposite reciprocals, they're not the same. Therefore, they're just intersecting lines.
Hi, Mr. Reedy, how you doing?
Oh, hi, Mr. Lynch. How are you? You're like a ninja. I didn't even hear you come in. What can I do for you, sir?
Okay. You know, oh, God, I know. Who's student 220233? You?
I think that's me. I need to check my ID.
That's all right. No, we'll do it later then. It's a misprint on me. I didn't realize it.
220233.
Yeah.
Yeah, that's me.
Could you come in? I have to have a word with you.
Okay.
Sorry to interrupt, Mr. Reedy.
Keep your guard up. He leads with his right.
Okay.
Okay. So,
You know,
similar manipulations of the same type of problem. We find that we want the slope of the line perpendicular to this line MN. Find the slope of MN, find the perpendicular slope. In other words, flip it over, change the sign. Okay, remember, you're changing the sign. So if the slope is negative, you make it positive. If it's positive, make it negative. It's not always just make it negative. You gotta change that around. Okay, I know I'm going through this fast, but I don't want to run out of time. Anybody satisfies the following conditions. This one we're going to talk about here. So now I've taken one of the values out of the slope, and I need to find that. So if I calculate the slope between these two lines, I would have -5 minus y over -3 minus 6 would equal what? -5, right, because it tells us the slope is -5. Solve this for y. How do I solve it for y? What do I do first?
Plus negative, so you get -9.
Okay, -5 minus y over -9 equals -5. So then bring that up here. -5 minus y is equal to 45. So move 5 to the other side. -y is equal to 50. So y is equal to -50. That's the missing y value we're looking at. This is similar to the problems we did where we had an endpoint and a midpoint. You had to find the other endpoint. So I took a chunk of information out of there. Have you solve for that chunk of information? We good?
Yep.
I think we might be able to get this in under the buzzer. Similar scenario, took a chunk of information out, plug and chug. There are our answers. Beautiful, day 5, got it.
By a minute.
Could have done that again if I tried. Okay, I will unlock day 5.